This week in Space Startup News, we cover a new propulsion system from MagDrive. Next up, Ursa Major successfully tests new Draper Engine. Our third segment covers Dawn Aerospace and their new docking and refueling port for satellites. And finally, Outpost wins a contract with the US Air Force to warehouse cargo in space. Okay, let's get started. MagDrive to test new propulsion system with D-Orbit collaboration. Before we talk about the mission, let me first introduce the MagDrive engine to you. The MagDrive engine is a compact, high-power propulsion system designed for satellites and spacecraft in low Earth orbit. Future plans will enable the drive to be used in deep space. The difference this drive has over other efficient thrusters, such as a Hall effect thruster, are the use of metal propellant coupled with an energy source to generate a high-energy plasma. The MagDrive engines boast thrust levels that are an order of magnitude higher than other electric propulsion systems of similar size. The complete system, which includes the propellant, onboard processor, energy storage, and plasma injector, fits within a single 2U CubeSat with a dry mass of only 2.5 kilos, that's about 5.5 pounds. Now you know something about the MagDrive, let's talk about the mission. MagDrive has teamed up with D-Orbit to test the MagDrive Rogue propulsion thruster. The mission was announced at the Small Satellite Conference and is scheduled for June 2025. Mark Stokes, CEO of MagDrive, said, "We're very excited to show the industry the potential of our MagDrive system. This mission is the first step to unlocking entirely new capabilities in high-cadence avoidance maneuvers, sustained RPO, and anti-SDA activity for defense in space. We are also extremely grateful to have the support of ESA, the European Space Agency, via their scale-up program for making the mission possible." Let me unpack that statement a little. First, RPO stands for Remote Proximity Operations. That is inspecting a satellite in orbit from a close distance. This is necessary before you can deorbit the vehicle, dock with it, or inspect it for damage, etc. SDA stands for Space Domain Awareness. It's a fancy way of saying that you know what is happening in space. Space is big and perhaps other countries are doing things you want to know about, including inspecting your defense satellites or even disabling them. Mark Stokes from MagDrive mentioned avoidance maneuvers. These are changes in orbit to avoid orbital debris. They are surprisingly common and more so year after year. In fact, the orbit debris issue is getting worse over time and, according to the European Space Agency, is not sustainable. High-thrust engines, like MagDrive, can contribute to being able to deorbit large chunks of debris and will be better at making faster maneuvers than other engines. The MagDrive Rogue is a cutting-edge electrical propulsion system that delivers thrust of up to 30 millinewtons, while maintaining a high specific impulse similar to existing systems. MagDrive will deploy 2 Rogue units on D-Orbit's Ion platform to demonstrate scalability across various satellite mass classes. The engine stores energy internally to ionize the metal into hot plasma, achieving higher thrust performance. It will be interesting to see how the MagDrive thruster works in space. We'll keep you informed on this mission. Next up, a successful engine test from a US company you may not have heard of. Ursa Major successfully tests new Draper engine. Ursa Major, a company that makes rocket engines, has announced the successful hot fire test of its Draper engine. The US Air Force Research Laboratory is funding the development of this engine. The Draper engine is a little unusual in that it has some advantages of a solid motor with storable fuel, while also having some of the high performance characteristics of a liquid engine. This allows it to act as a target hypersonic vehicle, which the US sees defending against as a critical area of work, given how China has large numbers of these hypersonic vehicles operational. This engine can be used for more than target practice though. Ursa Major will sell these engines to space startups that don't want the cost of a rocket engine development program. They can be used for launching small satellites into orbit to larger interplanetary missions. After all, other transport sectors don't manufacture every component in-house. Aircraft manufacturers buy engines from third parties like Rolls-Royce or Pratt & Whitney. Perhaps we will see more of this in the space sector in the future? Moving on to our next segment, another in-space refueling system is announced. Dawn Aerospace unveiled their Docking and Refuelling Port. Dawn Aerospace, a satellite propulsion provider, has introduced a new docking and fluid transfer port, called DFT, for their SatDrive propulsion systems. This innovation enables in-space refueling for their customers. By replacing a standard manual fill-drain valve with the DFT port, the weight is only increased by 600 grams, that's 1.3 pounds. The port supports 2 pressurized propellants, nitrous oxide, propane, or ethane, and includes power and data connections. Starting in 2025, all SatDrive customers will receive this new port as standard on their propulsion systems with a thrust of 10 kilonewtons or more. Several SatDrive customers are expected to use the DFT port, with the first launch scheduled for 2025. With low mass, low risk, and zero cost, we believe it's getting closer to a no-brainer decision for any Dawn customer who sees value in refueling, said CEO Stephen Powell. This allows customers to make the leap of faith, even though there are no established refueling services yet. Nitrous-based propulsion systems are ideal for in-space refueling. They do not require pumps for propellant transfer. Once a connection is established, propellant can be transferred simply by using the temperature difference between the two vessels. Stephen Powell from Dawn said, "We foresee potentially hundreds of refuelable satellites on orbit by the 2030s. That will go a long way to establishing a customer base for satellite refueling." Dawn Aerospace views in-space refueling as a means to extend the useful lifetime of satellites. The company's DFT port could also serve as a docking port for debris removal operations, which is becoming increasingly critical as the issue of orbital debris worsens. As a signatory of the European Space Agency's Zero Debris Charter, Dawn is dedicated to the sustainable development of space. And finally, in this week's space news, a US company gets a contract with the military to warehouse cargo in space. Outpost has secured a $1.25 million contract with the US Air Force to develop the capability to store cargo in space for on-demand delivery anywhere on Earth. Outpost is developing the ability to return payloads from space and deliver them to Earth with high precision. This development will benefit US troops by enabling them to receive supplies in remote locations around the globe. The US military is exploring the concept of rocket cargo, which involves delivering cargo using rockets. Although it may sound far-fetched, commercial space companies are actively developing the capability to launch and return orbital-class vehicles to and from space. These new rockets will have larger diameters and greater internal volume. Rockets can travel much faster than aircraft and can reach any location on the planet in less than 1 hour. Additionally, thanks to the Outer Space Treaty, there is no need to worry about overflight rights when traveling to and returning from space. Okay, that's it for this week. Don't forget to like and subscribe to our channel to catch our upcoming videos. We release new content every week, focusing on the lesser known space startups that often don't get the spotlight on other channels or platforms. We'll see you soon.